Hello class. Today we're going to do section 5, 7, 5, 8, and 5, 9. With today we're going to complete chapter 5. Okay? So 5, 7, 5, 8, and 5, 9. All right. There are some equations that we can factor just by recognition, okay? There are some equations that we can factor just by recognition. If you can recognize what you have in front of you, then you can just factor, okay? Those equations are difference of squares, difference of cubes, and sum of cubes. If you can recognize them, you can factor them just by recalling how to factor them, just by remembering. Okay? What is a difference of squares? A difference of square is exactly what it says. A difference, subtraction, and then two perfect squares. So subtraction, a difference, of squares. So just make a difference here, subtraction, that means difference, that's what it means. And then two squares, two perfect squares. All right? Okay, I'll just make this perfect square. 4 is a perfect square. X squared. That's a perfect square. I need another one. Here, make it 9. Look. Difference of squares. Okay. Guys, to factor this, the difference of squares is the product of conjugates. Okay? Is the product of conjugates. What are conjugates? Conjugates are this. The first term, exactly the same. So if this is 4x squared, this must be 2x and 2x. The first term, exactly the same. The second term, almost exactly the same. They're just opposites. Plus, how to get 9? 3, opposites, minus 3. Those four conjugates. The first term for conjugates, the first term is exactly the same. The second term, opposites. And you have factored. We have factored the difference of squares. The difference of squares equals the product of conjugates. Here's another one. Another difference of squares. Make a difference. And then two squares, okay? Two perfect squares. Let me see. Two perfect squares. Can I say 64 y squared? That's perfect square. Don't say no, say yes. And how about this one? Can I say 81 z squared? Yeah. Note, 64 is a perfect square. Y squared is a perfect square. 81 is a perfect square. Everything must be a perfect square. And we have to have a difference. Well, the difference of squares is the product of conjugates. Okay, no problem. Don't forget, conjugates, the first term, the same. Okay, so how do we get 64y squared? 8y, 8y. They're the same. If you multiply them, 64y squared. Okay, how about the last two terms for each factor? Well, they're opposites. One is plus, the other one is minus. We need 81, that's 9. 9. We need z squared, z, and z. And you have factor. Okay. Now, whenever you're factoring, don't forget, the first step in factoring is you always factor out the greatest common factor. And then you see if you have the difference of squares, the sum of cubes, the difference of cubes, a perfect square trinomial, and blah, blah, blah. But the first step is always take out the greatest common factor. Make sense? Let me look at some examples from the book, okay? Here are some examples from the book. Oh, here's a good one. Watch this one. Guys, look at this one. 3a to the fourth minus 3. Okay, look at this. So we have a difference, but is that a perfect square? Is this a perfect square? Is that a perfect square? Is this a square? Question. Is that a square? Question. Well, let me give you some squares, okay? I know a to the fourth is a perfect square. How do I know a to the fourth is a perfect square? Watch this. A squared, that's a perfect square, okay? A squared, that's a to the fourth, so a to the fourth is a perfect square. Is 3 a perfect square? No, 3 is not a perfect square, guys. This 3 is not a perfect square, so this term is not a perfect square. Not. This is not a square. This term here is not a square. No, because of the 3. This is not a square either. Okay. All right, very good. So this is not the difference of two squares, because that's not a perfect square and that's not a perfect square. Okay. So we do not have the difference of two squares. But I just told you guys that whenever you factor, what do? What's the first step in factoring? The first step in factoring is the greatest common factor. Okay? And what is the greatest common factor between these two terms? What is it? 3. So we're going to take out a 3. So the greatest common factor. Take out a 3. 3 times a to the fourth minus what? 1. Okay. So this came out. Now my question to you is the following. Is this the difference of squares? The answer is yes. We have a difference, a to the fourth is a perfect square, and 1 is a perfect square, and we have a difference. Okay? So therefore, this is the product of conjugates. Okay, let's finish it. So this is 3, and let's multiply two binomials. This a squared and a squared, those two are the same. and this is plus, and this is minus, and this must be 1 and 1. Okay? There we go, we factored. But wait a minute. We have another one. A squared minus 1 is also another difference of squares, so you have to factor it again. By the way, do not try to factor the sum of squares, okay? It's not factorable. Don't factor this one. Let's factor that one. So this is 3 times a squared plus 1 times a plus 1 times a minus 1. A. This one has been factored completely. Okay? All right. Do not try to factor the sum of cubes. No. Not factorable. Sorry, say it again. I just said it wrong. Do not try to factor the sum of squares. Not factorable. Do not try to factor the sum of squares. Do factor the sum of cubes. And do factor the difference of cubes. Let me show you how to factor the sum of cubes and the difference of cubes. Do not try to factor the sum of squares. The sum of squares, don't factor. Leave it as it is. And what is the first step in factoring? The greatest common factor, always. Look, here I started with this. I noticed that this is a difference. A to the fourth is a perfect square, but 3a to the fourth is not. So this term is not a perfect square. So what I did was I took out the greatest common factor, which is a 3, and that helped out. Now I end up with a to the fourth minus 1, and that's a perfect square. So I go ahead and factor this by the product of conjugates, and this is the sum of squares. We will not factor the sum of squares. Don't. But this is the difference of squares. We do factor the difference of squares. Yes. A product of conjugates right there. All right. And like I said, we factor the difference of squares. And guys, we also factor the difference of cubes. And yes, we also factor the sum of cubes. Let me show you. The sum of cubes. Let me start with the sum of cubes. Sum of cubes. Okay, I have to erase these guys. I'm running out of room. Okay. We do not factor the sum of squares. No, we don't. But we do factor the sum of cubes. We also factor the difference of cubes. So sum of cubes. What are cubes? Watch this. Cubes. X to the third. That's a cube. These are cubes. Perfect cube. Right there. How about this one? 2x squared cube. What is this? What's 2 to the third? 8. What is x squared cube. X to the 6. So that's a perfect cube. Yes, it is. Hey. So let me write here cubes. 1 is a perfect cube. 8 is a perfect cube. What's another one? 27 is a perfect cube. What's another one? 64 is a perfect cube. Why is that? Well, 64 isn't that 4 to the third? And isn't this 3 to the third? 27. 125 is a perfect cube. Why? Because this is 5 to the third. When you have a number raised to the third power, you have a perfect cube. X to the third, that's a perfect cube. What's another one? X to the 6. Yes, that's a perfect cube. Watch this. That's x squared to the third. That's x to the 6. What's another one? It's x to the, let me see. If x to the 8th a perfect cube? Is this a perfect cube? Question. The answer is no. Because what to the third power, x to the what gives you x to the 8th. If you say this power is 3, 3 times 3 is not 8. If you say 2, 2 times 3 is 6, not 8. So therefore, this is not a perfect cube. X to the 8th is not a perfect cube. No, it isn't. Not a perfect cube. What's another one? X to the 9th. What's another one? X to the 12th. These numbers must be divisible by 3. Look, 12 divided by 3 is 4, 9 divided by 3 is 3, 6 divided by 3 is 2, 3 divided by 3. These are all perfect cubes. Okay. Sum of cubes. All right, just come up with some of those. 27 x to the third plus 8. Perfect cube. Perfect cube, sum. Can we factor this? Yes. How do we factor this, guys? How do we factor this? This is a binomial times a trinomial. The binomial is going to have the sign of the original problem. If the original problem is a sum, this is a sum. If the original problem is a difference, that's a difference. The trinomial. The trinomial has two signs. It's a trinomial. The first sign is the opposite of this. If this is plus, this is negative. If this is negative, this is plus. And this last one, this last sign of the trinomial is always a plus. I'm giving you the formula on how to factor sum of cubes and difference of cubes. Okay. It's a binomial times a trinomial. For the binomial, the first term is always what is being cubed in the first term here. So can someone tell me what's being cubed? What's being cubed? I see a 3 is being cubed, and I see an x is being cubed. For the second term, we ask what's being cubed. I know 2 is being cubed. I'm showing you how to factor the sum of cubes. For the trinomial, we ask, the first term we ask here, no, I'm sorry. For the trinomial, square this term. For the trinomial, the first term in the trinomial, just square this. What is this? What's 3x squared? 9x squared. This last term in the trinomial, square this. 4. For the middle term, multiply those two. Multiply. What's 2 times 3x? 6x. Okay. All right. By the way, this trinomial is always prime. That means not factorable. You do not try to factor this. It's always prime. Okay, so how did I get the sign? From the original problem. How did I get this sign? The opposite of this. How did I get this sign? That's always plus. How did I get this term for the binomial? Whatever is being cubed. What's being cubed? 3x. How did I get this term? Whatever is being cubed there. What's being cubed? 2. How did I get this term? Square this. How did I get this term? Square that. How did I get the middle? Multiply those two. There we go. Let's do another one. Let me see. Let us do a difference now. One 25 x to the third minus y to the third. Is this the difference of cubes? Yes, it is. It's a pattern. It's a binomial. Just follow the pattern. Times a trinomial. This is a trinomial. What's the sign in the binomial? Same as the original problem. What's the first sign in the trinomial? The opposite of this, the opposite. What's the last sign in the trinomial? It's always a plus. How do we get this first term in the binomial? What's being cubed? 5 is being cubed and x is being cubed. 5x. What's the first term what's the second term in the binomial? What's being cubed? Y is being cubed. What's the first term in the trinomial? The first term, square this. Go ahead and square 5x. What's 5x squared? 25x squared. What's the last term in the trinomial? Square this. Y squared. What's the middle term? Multiply those two. Multiply 5xy. Ignore the sign, okay? Just multiply this y times the 5x. There it is. What's the first step in factoring? The first step in factoring is always to take out the greatest common factor, guys, okay? We always take out the greatest common factor, okay? So let me give you an example here, okay? Watch this. Watch this. Don't forget the greatest common factor. So what is 3x to the 5th plus 24x squared? What's the first step in factoring? Take out the greatest common factor. What is it? Take out an x squared. So the greatest common factor is an x squared. Take it out. The greatest common factor is 3. Said it wrong, okay? It's 3 x squared. 3 x squared. Take it out. So 3 x squared comes out. What stays behind? X to the 3rd plus 8. Multiply to check. 3x squared times x to the 3rd is 3x to the 5th. 3x squared times 8, 24x squared. Okay. What is this? This is the sum of cubes. Can we factor it? Yes, we can. So let's not forget about this one. 3x squared. And this is a binomial times a trinomial. The sign of the binomial is always the same as the original problem, right there. The first sign is the opposite of this. The last sign is always a sum. For the first term here, what's being cubed? X. What's being cubed for the second term? What's being cubed? 2. For the first term there is square this, x squared. For the last term is square this, 4. For the middle term, multiply those 2, 2x. And this one here, this trinomial, is always prime. That means do not try to factor it. Okay, so don't forget, the first step in factoring is always the greatest common factor. Okay? All right, so that's how we factor difference of squares, sum of cubes, difference of cubes. We can factor all 3 of them. When it comes to sum of squares, do not try to factor. Don't. Okay? Now, I'm going to show you how to solve quadratic equations. Quadratic equations, guys. What is a quadratic equation? Take me a long time. I need an eraser. But I don't want to go to the store or the supermarket because, or Walmart, because of what's going on with the coronavirus. I'm trying to stay away from those places, okay? So, quadratic equations. Solving quadratic equations. What's the first step in solving quadratic equations? First of all, what is a quadratic equation? Here is a quadratic equation. X squared minus 4x equals to 45. This is a quadratic equation. What makes it quadratic? This greatest power makes it quadratic. Okay? So we look at the greatest power because the greatest power is 2 in this equation. That makes it a quadratic equation. How do you factor quadratic equations? Quadratic. How do you factor quadratic equation? The first step is to set it equal to 0. Step number 1, set one side. That's a 1. Set one side to 0. Or set one side equal to 0. Okay. How do you set one side equal to 0? This one here. How do you make this side equal 0? Subtract 45 from both sides. Okay. Or just bring it over to the left. X squared minus 4x minus 45 equals 0. Okay. That's the first step. Make one side equal to 0. Second step. Step number 2. Factor the non-zero side. That's the 0 side. This is the non-zero side. I'm going to factor this. Okay? To factor this, that's the product of two binomials. This must be first. How do you get first? That's this times that. X times x. Got first. This must be last. Last. How do you get 45 in last? 9 times 5 is 45. And it's negative. It's negative. So one has to be positive, the other one negative. Okay. Now you check outer and inner. What's outer? Outer is negative 5x. This is outer. Inner is, that's inner, 9x. When you add them up, that should add up to the middle term. This is the middle term. Middle. Is it 2 D's? I think so. Yes, I think it's 2 D's. Middle term. Right there. So this, when you add them up, you better get negative 4x. Let's see. Negative 5x plus 9x, that's 4x. Do we get negative 4x? The answer is no, we don't get negative 4x. But we get the opposite, so we're almost there. So therefore, this is almost the right combination, but it's not quite yet. So all we have to do, when you get the opposite, all you have to do is change the sign. This is minus and this is plus. And then you better check again. To check again, let me see. Outer. Outer is positive 5x. See? X times 5. 5x. Inner. Inner is negative 9x. Add them up. Negative 4x. That's the right combination. We got it. We got it. Yay. So we factored. And now, first step, use the zero factor property. Here's what you do. You raise your hand and say, by the power of the zero factor property, here's what the zero factor property tells you to do. You say, by the power of the zero factor property, the first term, x minus 9 equals 0, or the second term, x plus 5 equals 0. That's the zero factor property. You set each factor equal to 0. But you gotta say by the power of the zero factor property, okay? So So by the power of the zero factor property, x minus 9 equals 0 or x plus 5 equals 0. Now solve this one. If x minus 9 equals 0, x equals 9. If x plus 5 equals 0, x equals negative 5. And these are the answers to this, okay, quadratic equation. If you don't believe me, plug it in. Check. Check x equals 9. Plug it in. What's 9 squared? What's 9 squared? 81. Minus. What's 4 times 9? 36. Equals to 45. Okay? So borrow 11. 11 minus 6 is 5. That became this became a 7. 7 minus 3 is 4. Got it. It works. Check again. Check this one. X equals negative 5. Plug it in. What's negative 5 squared? 25. Minus. What's negative 4 times negative 5? What's negative 4 times negative 5? Plus 20. True or false? This is true. And this is true. Yep. Here we go. This works. Okay. By the zero factor property, by the power of the zero factor property. Let's do another one. Watch this one. Here's a good one. Here is x equals 2. 6 over 7 x squared minus 3 over 7. And my question to you is this a quadratic equation? And the answer is yes. What makes it quadratic? Well, let's look at the power, the greatest power of the variable. If the greatest power of the variable is 2, that makes it quadratic. What's the power here? 1. What's the power there? 2. Hey, that's the greatest power. This makes it a quadratic equation. So this is a quadratic equation, and we're going to follow the 3 steps. But before we follow the 3 steps, we better get rid of what? Let's get rid of fractions. All right. How do I get rid of fractions? Multiply this by 7. Multiply this by 7. 7 is going to cancel a 7. And multiply this by this by 7. 7 is going to cancel a 7. I multiply everything by 7. Okay, so now we're ready to apply the 3 steps. What's the first step? Set one side equal to 0. Oh, by the way, you better write it in descending order, okay? Because if you write it in descending order, it's gonna be easy to factor. So set one side equal to 0. First step. I'm gonna bring this to the right, or subtract 7x. And on the right-hand side, I'm gonna write everything in descending order. So 0 equals 2, 6x squared minus 7x minus 3. So I took step number 1. Step number 2, factor the non-zero side. That's the non-zero side right there. That's the 0 side. Let's try to factor this. 0 equals 2. Well, because this is a quadratic trinomial. quadratic trinomials are the product of two binomials. Okay? Obviously, the first step is to try to take out the greatest common factor, but in this case, the greatest common factor is just one. This is first, and this is last. And look at last. Last is easy. I'm going to say 3 times 1 for last. And it's negative, so I'm going to say plus and minus, you see? If you multiply 3 times -1, you get -3. Got it. Okay. Look at first. 6x squared. That's this times that one. How do you get 6x squared? Don't worry about it. Just try two values that multiply to 6x squared. I'm going to say 2x and 3x. Okay? So you make first and last work. And then you check outer and inner. What's outer? -2x. What's inner? 3 times 3x, 9x. You add them up, 7x. Go back and check. Oh, wait a minute. We need a -7x. Because they're opposite, we got the opposite, no problem. We almost have it, except for the sign. This is positive, let's make it negative. This is negative, let's make it positive. And then let's check again. 2x times 3x, 6x squared, got it. -3 times 1 is -3, got it. What's outer? Outer is 2x times 1, 2x. Inner is -3 times 3x, -9x. Add them up, -7x. Yay! Got it. We factor. Okay? We need the room. Now, we took the second step. Let's take the third step. And we say, we raise our hand and we say, by the power of the zero factor property. By the power, you have to say that, okay? If you don't say, you're going to get it wrong. I'm sorry. I'm kidding. By the power of the zero factor property. By the power of, you have to say it. By the power of the zero factor property, 2x minus 3 equals 0. Or 3x plus 1 equals 0. What allows you to do that? The zero factor property. The zero factor property tells you that when you have the product of factors equal to 0, by the power of the zero factor property, the first factor equals 0. First factor equals 0, or the second factor equals 0. If you have 3 factors, then the first factor equals 0, the second factor equals 0, the third factor equals 0. Okay? Now solve. 2x equals 3, or 3x equals -1. Continue solving. X equals 3 halves, or x equals -1/3. And we have solved. We solved this. Look at that. Nice. We were able to solve this quadratic equation by the power of the zero factor property. The 3 steps. Okay? You need the 3 steps. Okay? Okay, guys. That completes section let me do one more. Here's another one. Which one should I do? Let me do this one. Watch this. Here's a good one. 5x cubed plus 13x squared equals to 6x. Note, or I should ask, is this a quadratic equation? The answer is no. This is a cubic. You look at the greatest power. Cubic equation. Can we apply this? 3 steps. Yes, we can. Okay, you can apply this to any polynomial equation. That's the nice thing about this. Okay. So, what's the first step? Set one side equal to 0. Okay. 5x cubed plus 13x squared minus 6x equals to 0. Okay. What's the second step? Factor the non-zero side. What is the first step in factoring the non-zero side? Let's take out the greatest common factor, which is what? X times 5x squared plus 13x minus 6 equals to 0. This is a quadratic trinomial. We have to try to factor this. By the way, here we found one factor right there. That's a factor. So x, keep it, and then try to factor this. Look at 5x squared. That's first. First is this term times that term. First. 5x times x. That's 5x squared. Look at last. Last is 6 negative. Don't worry, just find values and multiply to 6. I'm going to say 2 times 3. And look at the sign. Negative. So make one of them positive, the other one negative. I'll make this negative, I'll make this positive, and I'm not going to worry about it because I'm going to check at the end. Okay, checking. Now let's check. 5x times x, 5x squared. That works. Negative 2 times 3, negative 6. That works. What's outer? 5x times 3, 15x. What's inner? Negative x, negative 2 times x, negative 2x. Add them up. Add them up. 13x. Does that equal to this? Yay! We got it. This equals to that. Nice. Okay. Now, we're ready. Yes, we are. To use the third step. So let's do the third step. Raise your hand. By the power of the zero factor property. What's the first factor? This one. By the power of the zero factor property, x equals 0, or power of the zero factor property, 5x minus 2 equals 0, or, that u means or, okay? Or, power of the zero factor property, x plus 3 equals 0. Mm-hmm. Let me erase this, okay? There we go. And so now, this x equals 0. Or, this 5x equals 2. Or, this x equals negative 3. Mm-hmm. X equals 0, or divide by 5. X equals to 2/5, or x equals negative 3. Guys, when the greatest power is 3, we should have 3 answers. If the degree is 2, we have 2 answers. Here the degree was 2, we have 2 answers. Here the degree is 3, we have 3 answers. Sometimes they are repeated answers. Okay? There we go. Solved. Using these 3 steps. Okay? All right, I'll give you one more. One more. Okay, one more problem, because I want you to understand these concepts. Watch this next problem. I'm going to show you an easy way to solve the next problem. 2x plus 1 quantity squared equals 2. Negative 8 times 2x plus 1 minus 16. Okay. Is this quadratic equation? The answer is yes. Because eventually if you square this binomial to the second power, you're going to get a quadratic term. And it's going to make it a quadratic equation. There's the long way to solve this equation, and there's the short way. I'm going to show you an elegant way. Okay? Let me erase this. And that's the last problem, okay? That's the last problem. That, but it's fine. Okay. If you ever see that you have the same binomial on both sides, and you have one of the binomials being squared, and they're the same binomials, you can do a wish. Make a wish. Make a wish. And what's your wish? What is it that you wish? I wish this was quadratic. I wish the equation was quadratic. You can make your wish come true. Yes, you can make your wish come true. How? By substitution. Mm-hmm. To make your wish come true, let this 2x plus 1 and this 2x plus 1, let 2x plus 1 be a different variable. Okay, so to make your wish come true, to make wish come true, let whatever the repeated binomial is, let that binomial, let 2x plus 1 equals to a different variable, z. You're trying to make your wish come true. So if 2x plus 1 equals z, this is 2x plus 1, and that's 2x plus 1. Look what happens. 2x plus 1, which is z, 2x plus 1 is z, z squared equals 2, negative 8z minus 16. Look at that. Your wish came true. Mm-hmm. You made it quadratic. Now this is only possible if we have the same binomial. Forget that. So your wish came true. Now we're going to solve your wish. Yes, we're going to solve what you wished. We can solve this now. How? How do we solve this? The 3 steps. your wish. How? Set equal to 0. Z squared, bring it over, plus 8z, bring it over, plus 16 equals 0. So we did this one. Second step, factor. Okay. Factor. That's a z times z. That's a 4 times 4. And that's a plus and a plus. Note, you are solving your wish. You wish that the original problem was quadratic. To make your wish come true, you let z equals to whatever that binomial is, and that should be the same binomial. If you had different binomials, you can't do it this way. And now you're gonna solve your wish. I'm solving my wish, and so by the power of the zero factor property, z equals to -4, and or z equals to -4. Wait a minute, those are the same answers. Okay, so all we need to do is solve one of them. But wait a minute. This z is your wish. Okay, now you need to go back to reality. This is reality right here. This is reality. Reality is that you want to solve for x. You don't want to solve for z. Z is your wish. Now let's go back to reality. What's the reality? Reality is that the z needs to be 2x plus 1, because reality is you want to solve for x. So therefore the z, this z is 2x plus 1 equals -4. And this is the same thing all over again. 2x plus 1 equals -4. Okay? So if I solve one of them, I got the answer. I'll just solve for this one. Subtract. Subtract 1. So 2x equals to -5. I'm solving reality now. Reality is I want to solve for x, not for z. And then x equals to -5 halves. Got it. Yeah. We solved. We solved. The answer to this is x equals -5 halves. Okay. All right, class. Now you can finish section 5.7, 5.8, and 5.9. Thank you very much. Have a nice day. I'll see you soon. Okay. Bye.